Chapter 9.2, Experimental Probability. So experimental probability is different from theoretical probability in that you're actually doing something. You are actually trying various things. You're flipping the coin, you're tossing a dice, you're making a free throw from example 1. So the probability that an event will occur is the number of times that event occurs over the total number of trials. For example, the probability of getting heads when flipping a coin will be the number of heads that you get over the total number of times you flip. Now on the back counter, there are some dice. If you have coins, anything, actually try using do the experiments, okay? If it tells you to flip a coin 40 times, flip a coin 40 times. Work together with a partner. If that will help, you guys can definitely work together. So let's take a look at example 1. You attempt 16 free throws in a basketball game. Your results are shown. What is the experimental probability of making a free throw? So the probability of getting that free throw is a fraction. The number that you make over the total that you try. Well, we know that we attempted 16. And here I see that I made 1, 2, 3, 4, 5, 6, 7, 8. You made 8 out of those 16. With probability, you always want to reduce to simplest terms. So 8/16 is equal to 1/2. So the probability that you're going to make that free throw is 1/2. Example 2. A bicycle company checks a random sample of bikes. The results are shown. Here I see that they checked 400 bikes. 12 of those bikes were defective. If the trend continues, which is the best prediction of the number of defective bikes in a batch of 1,300 bikes? So we're going to use proportions in order to figure out the probability. So I know that 12 out of 400 were defective. I can reduce that by dividing both by 4 to 3 out of every 100 is defective. So if 3 out of every 100 is defective, how many are defective out of 1,300? Well, to go from 100 to 1,300, I'm going to multiply by 13. I'm going to do the same thing here. Multiply times 13. And 3 times 13 is 39. So I can estimate that 39 bikes will be defective out of those 1,300 that were made. Example 3, I want you to actually use coins for this one. So get 3 coins or 3 round 2-sided objects that you can flip and find the experimental probability that 2 of 3 children in a family are girls, and assume that boys and girls are equally likely. That would mean like the side of a coin. Tails is boys, and heads equals girls. So if you toss that coin, and the first time you get a tails, tails, heads, write it down. Flip again. Tails, tails, heads again. Flip again. Tails, tails, tails. All boys. Flip again. Heads, heads, tails. Whenever you get a heads, heads, tails, I want you to circle it. Okay? If you continue to do that 20 times, If you look in the example of the book, okay, you're going to have 20 flips. Record each one. When you are finished, out of those 20, how many were heads, heads, tails? Looking at the full chart in the book on page 348, you will see that there were 1, 2, 3, 4, 5, 6 out of the 20 tosses were heads, heads, tails, which reduces to 3 out of 10, or 3/10. So the total number of times that 2 heads and 1 tail came up were 3 for every 10 times that you tossed the coins. So that is the experimental probability. Okay, again, please make sure that you actually find each experimental probability. If it asks you to toss the coins, toss the coins, toss dice, toss dice. If it gives you all the information you need, that's fine. You can just work with that. Complete your QCs and CYUs, and if you have any questions, come and see me.